Hello guys, today we are about to answer the following questions using the banker's algorithm. First, what is the content of the matrix need? Second, is the system in a safe state? And lastly, if a request from process P1 arrives for 0420, can the request be granted immediately? So to answer these following questions, we should consider the snapshot of a system here presented above. So here we have 5 different processes, each has corresponding resources, which is then divided into their allocation matrices, max and available matrices. So to answer the first question, we shall now proceed to the next slide. In this slide, we have the content of the need matrix, which is calculated by subtracting allocation matrix from the max matrix. So in order to get the need matrix of each processes, we should take a look back in the main table. So here the main table in the red ones, we have the values for process 0 of in the max matrix, which has 0, 0, 1, 2, and in the allocation, which has 0, 0, 1, 2. So in order to get its need matrix for process 0, we should subtract allocation from the max matrix. So 0, 0, 1, 2 minus 0, 0, 1, 2, we have the need matrix equal to 0, 0, 0, 0 for process 0. And to the next process P1, we have the allocation matrix value of 1, 0, 0, 0 and max matrix value of 1750. Subtracting allocation from the max matrix of process P1, we get the need matrix of 0750. So that's how we compute to get the need content for the need matrix. So now let us proceed if the system is in a safe state. So to check if the system is in a safe state, the available matrix now is 1520, which we can see here in the process 0. And the process that after it has finished execution is supposed to free up all the resources it holds. We need to find a safety sequence such that it satisfies the criteria need or need matrix less than or equal to available. Since need of the process 0 matrix is less than or equal to available, we select process 0. So here in the process 0, available matrix is equal to available matrix of process 0 plus allocation matrix of process 0, which will have the values of 1520 plus 0012. We have now the current available matrix of 1532. So that goes on to the next processes, as we can see here in process 2, process 3, process 4, and process 1. We get the value by using the formula of the current available matrix of the process. So the safe sequence is P0, P2, P3, P4, and P1. So in conclusion, we have a safe state. So now let us proceed through the question number 3. So our request from process P1 arrives for 0420. So in this process, first, the system receives a request for P1 for request process P1 0420. And first, we check if request P1 is less than need P1, which has the value of 0420 less than 0750 is true. Now we check if request process 1 is less than available 0420 less than 1520 is true. So we update the value as available is equal to available minus request, or 1520 minus 0420 is equal to 1100. And in the allocation, equals allocation of process 1 plus request is equal to 1000 plus 0420 equals 1420. And in the need, we have need of P1 minus request equals 0750 minus 0420 is equal to 0330. Now we have the modified table, which give us a new values of the matrices of process P1 in its allocation, which has 1420 rather, and in the max matrix we have 1750, and in the need matrix we have 0330. And now the available resources for process 0 is changed to 1100. So on verifying, we see that the safe sequence still remains the same. The system continues to remain in a safe state. So that's all, and thank you.